Hello, data enthusiasts. This is Chris Detzel, and
I'm Michael Burke.
welcome to Data Hurdles. We are your gateway into the intricate world of data where AI, machine learning, big data, and social justice intersect. Expect thought-provoking discussions, captivating stories, and insights from experts all across the industries as we explore the unexpected ways data impacts our lives. So get ready to be informed, inspired, and excited about the future of data. Let's conquer these data hurdles together. All right, welcome to another Data Hurdles. I'm Chris, and
I'm Michael Burke. How you doing, Chris?
I'm good. How about you?
I'm feeling good. Recovered from that long siesta that we had, essentially over the summer. Relaxed. I don't know if I brought it up in our last podcast, but I've changed jobs and kind of changed careers in a big way over the last couple months, which has been a super exciting transition for me. To give a little personal information, I went from a large enterprise organization to a startup, essentially, or a venture capital company doing startups, which has been really exciting, but a complete culture change, completely different than anything I've done in a long time. So really refreshing and exciting.
Wow, is it doing AI and ML stuff or something different than that, or what?
Still doing AI and ML, but building products from the ground up. So this new company that I'm working for, Boston Venture Studios, we take an idea and we go from idea to prototype to MVP in a course of a very short and condensed period of time. And we build 12 ideas a year to try to launch into the market.
Wow, that's pretty awesome. Wow.
Yeah.
It's different, way different than what you are doing. I mean, you're still doing AI and ML, but a little bit in a different way for product-specific companies. Wow. Well, congratulations on that. That's pretty cool. And I look forward to having some more conversations around maybe future stuff, that you can kind of dive into if all possible one day. So
thank you. Yeah, absolutely. I'm sure we'll dive into a lot more of that.
Yeah. Today, one of the topics that has been coming up, and I've been even hearing in the market a little bit, is this thinking around edge computing. And, I don't know if it's definitely not a buzzword, but I'd like to talk to you a little bit more about that, Michael, and just kind of what is it, what can we learn from it? Help us understand that. What is edge computing?
Yeah. So traditionally, edge computing is this idea of processing data closer to the source, right? So when you think of processing data, a lot of people would think of like transactional databases or these like servers that are doing something with data, but it can also be creating data closer to a source. And so when you think about your traditional cloud source system, right? Cloud data system, you have, let's say, a mobile phone and you're using an app, and that app reaches out to the cloud, asks for some data, the data is processed and it gets sent back to the phone, right? Edge computing is saying, how can we bring and shorten that distance and that time so that maybe you have something that's processed on the phone, or maybe data can be created on a phone, like in the use case of a large language model. So it's really bringing the system that processes data closer to the actual device that consumes it. And what does that get us, right? That gets us an extreme efficiency on reduced latencies and also costs.
So it's way cheaper. So quickly, as I kind of think about this, is companies like the company I'm at, we talk about being SaaS, going, we're in the cloud, and and that's being a huge differentiator than being on-prem or whatever. Can you is that kind of the future of companies like mine? We now go to the edge instead of the cloud, or is that different?
Yeah, I mean, I think that for some use cases, obviously, you're never not going to need centralized computing. You're always going to need centralized computing, right?
Okay.
Because at some point, you need to bring together or centralize data on your users or their interactions. But what is different is edge computing can run almost decentralized, right? So if you think about being able to have, thousands of servers around the world that work independently to serve a specific geographic region, that could be something that's bringing you closer to edge computing than just having one server that serves the world. What we're talking about now is actually saying, well, can we have that thing that serves and processes data on your phone or on your device, on your machine, on your factory floor that's running and doing analysis for you? And that's going to provide a very specific use case that's going to provide tremendous value for these companies where significantly a small change in reducing cost or a small change in reducing latency is going to add a tremendous amount of value, right? And in many cases, that will be a competitive advantage when the technology first becomes available.
So it's not available yet. So we're getting all excited about this. Not available.
It is available in certain use cases, but it's not broadly used, right? Edge computing is still something that is a newer thought way of thinking. Developing around and designing applications using edge computing is definitely something that we're just starting to see in the market, and it's in its very early stages.
Okay, cool. Sorry, I didn't mean to get off, but I was a little interested in cloud versus So why is it so important? Help us understand that.
Yeah, so I think a really good thing was think about like a large manufacturing company, right?
Okay.
They have a machine that, is doing something. Maybe it's, building something or monitoring something or polishing something. That machine, if anything happens to it, right, could cost the company millions of dollars, a huge amount of money, and it might take weeks or months to restart if it's a large manufacturing machine.
Yeah.
Today, what we do is we send data up to servers, either real time or in batch, and then we get back results on how that machine is functioning, right? As an example. With edge computing with cloud computing, you have to send that data all the way to a machine and it has to send it all the way back. And in some use cases, even those milliseconds or seconds of latency to do that processing could be the difference between, damaging a machine and causing weeks of delays versus shutting it down and being able to quickly swap out a part. And so when you think of edge computing, it is doing all of that processing, all of that calculation in real time. That's one good example. Another really interesting example is a large portion of the world does not have stable internet, right? They don't have a strong internet connection. And when you get into rural parts of the world, that means that you have less access to things like educational tools and other things that require you to connect to a centralized network or a cloud.
Yeah.
What edge computing could do for them is you could offer ways for them to interact or learn through a machine that generates data like a large language model offline, right? Where your device is actually responding and generating information that the user's interacting with. So I think that, there's lots of different use cases for why edge computing is super beneficial, and why it will change a lot of areas to make things faster and more efficient. One other really great example is, environmental, right? Today, we have to send data across maybe even the entire world and get back a response. Whether we like to believe it or not, that's a huge amount of energy for one request. So it's not just about latency, and it might not be a lot of energy for just one request, but we're talking about billions of requests a day across billions and billions of users. That's a huge amount of information. And the closer you can bring things together, not only is it more cost effective, but it's a lot better for the environment because it's using less energy.
Well, I think that's good. And especially when you start looking at those large language models, right? Like it's just the amount of energy. And I think I showed you this graph is by far, more than anything out there. I mean, by far, it's pretty crazy. That's probably a topic that we should talk about at some point.
It is incredibly scary. And there was a stat that I just read. I don't know if this is true or not, but it said between 6 and 50,000 tokens that large language models used consumes an average of 500 milliliters of water to cool the GPUs in these systems that are cooling things. And you look at these stats and, again, that's not a validated stat, so I wouldn't run on that by any means, but there's a huge amount of energy. And this is a huge problem that we're not taking seriously right now. And it's only going to get worse very quickly.
The sustainability is not good. It's not.
Yeah.
So when we kind of look at the data, of like this edge computing and why it's important, like what is that, you can give me an example of like, okay, with the large language model, you're feeding this data and all this other stuff, so I can get that. But I guess I'm not completely understanding how the data goes in and out and where it goes and all that kind of stuff from it. Because I understand like cloud goes up to the cloud. You can access it anywhere. I'm still not completely
Yeah. So
understanding exactly all this stuff. So go ahead.
If I was to take a large language model, and today we're talking about using ChatGPT, that's what most people are using, or Burke, or these other big models. But those models are getting smaller and more efficient and more accurate at solving specific tasks, right? And so if you can get a model that's more efficient and uses less energy and less memory, you could actually put that on a mobile device. And so when we talk about edge computing, right? If I submit data to my phone, like a question, and then the phone is able to generate data back from a large language model that's running on my phone, that is like as close as we've been able to get to edge computing today, where the data is being generated and processed all on the same device that I'm actually inputting the data. It's not leaving and going to the cloud. It's not going to a ChatGPT server. The model lives on my phone, which means that I don't even need the internet to interact and engage with this application because it's generating its own data.
Feels like it's like is it something you download, or is it something that's already there, or will be on the phone, or I guess I'm not really. How do I get this? You know what I mean? Like, how do I put it on my phone? Like,
well, you'd still need to download it today from like a centralized source, right? You always have to get the model or the app. But the idea is, you will have access to the app once it's on your phone from anywhere. And you can use it for anything at any time.
Okay. All right. So, the other piece on data, you mentioned that it unlocks real-time insights given business. Well, you didn't say that, but can you talk more about how it unlocks like real-time insights and gives, the businesses more of an edge or a competitive edge? I mean, is there an example yet about that? Or
yeah, so all of these places that we need to collect and process data, when we think about the internet today, you might think about places where you're already connected to the internet.
Yeah.
But there's so many places and so many use cases where data needs to be collected and processed without the internet. Another really good example is tracking and monitoring endangered species or wildlife, where, these technologies that we have today need to be able to operate in an offline state or an edge state where they're able to collect, process, and identify things without any kind of connectivity.
Yeah.
That is another great example. If you think about some of the other examples like agriculture, right? When you're out on a farm, there are just new technology that's able to identify and kill or zap weeds on a farm where there is no internet. And
I didn't know where you were going with that, but okay.
Yeah. That machine needs to make those decisions without any internet, right? And it wouldn't be a productive machine if every time it had to make a decision, had to send something up to the cloud had to make a decision and then send that decision back. All the intelligence is processed on the edge, on the device, on the machine.
Okay. All right. That makes sense. What are some of the benefits?
Yeah. So when you think about like what kind of technology that unlocks us to do so much more with the data and the intelligence that we have, right? So huge amounts of cost reduction, huge amounts of efficiency gains, and that leads to more accurate systems, right? That drive, huge performance gains, huge efficiency gains, and allow us to operate in a more intelligent and unmonitored state, right?
Got it. So you gave us some examples of some, use cases sort of, but do you have any like real life examples, like companies doing some of this of using edge computing? Do you know?
Yeah, absolutely. So there's this company, Moog Inc., right, that uses edge computing for applications and architecture. Honeywell, and a lot of it, I'm sure Google and all these Nest and all these other companies, they use edge computing to be able to optimize energy efficiency of large buildings, right? So they're not necessarily sending all of that information back to a server. They're communicating between the devices in that building to figure out, okay, this is how we optimize the energy spend for this building.
Yeah.
So it's its own micro network or micro ecosystem that's training, learning, and getting better all on the devices or within the devices in that ecosystem. Another really interesting one that there's a lot of development right now is innovation in the UAV space, the drone space for military use cases. When you think about drones and these kind of unmanned object or unmanned vehicles flying through systems and spaces where they probably won't have internet. And actually, there's probably other government agencies that are trying to prevent them from having any kind of signal or connectivity to the outside world because that's a threat to them. They have to be able to make decisions autonomously and independently of any kind of connection or cloud system or even human. And so we're seeing a lot more of that.
Crazy.
Yeah, and we're seeing a lot more of that. And, can drones fly in networks or meshes where they can communicate with one another to send data to ultimately a cloud system, right? Can they make these kind of decisions without a human or without a connection? And these are real spaces where billions of dollars are being put right now to try to make more advanced technology to protect, countries ultimately.
Do you think that it's just gonna AI and ML stuff just took off, right? And it still continues to kind of be the talk of everything. But is edge? I've heard of it, right? You hear it every now and then, but I've never gone into this depth and to understand it. But is this something that's just going to take off one day and then everybody can use it, or is it too expensive to kind of do? I think what does that look like?
Standard. I think it's going to be the standard in the future. When you think about computers, right? When computers first came out, a computer was the size of an entire floor of a building.
Yeah.
To do simple math calculations.
Yeah.
And then the desktop computer came out, and then the mobile phone came out. And when a mobile phone first came out, it
laptop came out first.
Yeah, sure.
But yeah.
But these devices, they're able to do more and more. You think of all the innovation that we've had. It is completely acceptable to think that eventually we won't need a centralized network for most of the interactions that we have in the world with technology. And I do think that already when you think of devices like smart home devices and enterprise devices for efficiency and machines and manufacturing devices, they're all moving in that direction, right?
Yeah.
This is something that probably in the next 5 to 10 years will be a standard practice, and it will require a whole different type of engineer and developer to be able to design systems that operate on the edge.
So it's going to take new thinking. Something I heard at not to get completely off, but at a Forrester research conference this last week, is that it's George Colony, he's the CEO of Forrester, and he said, the way that the internet looks today changes in 3 to 5 years. Think about it.
Yep.
Like Google, when you search on Google, you get a bunch of stuff, and it's kind of messy. You know what I mean? And it's just okay, I got to search for what I'm looking for, even when you search, and you can't easily find it. But, now what they'll start doing is pushing the internet or pushing LLMs, ChatGPT-like stuff, not necessarily that, but into let's say a bank. You go to usbank.com. It changes everything. Hey, I'm looking at my balance. What is my balance? Oh, it's this. Hey, what are my last 5 transactions? It's this one, this one, this one, and this one, right? It changes now. It talks to you rather than, and you don't have to search for it and click all these buttons and shit. You know what I mean? It just tells you where all your stuff is. That's, in a way, game changing and how the internet works. How does the edge computing, you sort of mentioned it, but is it that kind of game changing, or is it I would know about it, or is this more of behind the scenes kind of stuff that,
I think it's completely game changing. You think about how you would experience it. You're a runner, Chris. You're a big runner, right? Yeah. You've got your watch, your smartwatch. Imagine if your smartwatch could be your pacer coach for anywhere in the world. It had that data for you, and it could tell you when your heart rate was higher than it should be automatically because it knows that much about you, all operating on an edge anywhere you are in the world. Or it could diagnose your health issues. Maybe it recognizes some obscurity in something that's happened with your body from a sensor, mobile wearable sensor that you have on your wrist, right? these types of processes will become not only better and more efficient, but it's also going to be a lot more secure because if you don't need the cloud, then you have much better data privacy, right? Processing data locally will significantly reduce the amount of risk that you have on your device, right? Because anybody who wants that data has to get it off your device versus if it's all a localized closed system, you have a lot more control and authority over that data, which I think that when we talk about wearable health devices and, we start moving into the medical space and like assisted medical care, things like this, where you really don't want that data being shooting around centralized servers. This is a really, I think, interesting and desirable use case that a lot of people would want.
This feels like bring your own on-prem.
Yeah, exactly.
Like
that's what it is.
It's going back to on-prem, but it's like BYOP or whatever it is. Bring your own on-prem. So we're kind of going backward. We're not going backwards, but it's kind of like it's like is it private cloud? Is that what they call it, or something like that, or what's the?
Well, just think about it. It is on-prem, but you've taken an entire server of information and you've been able to reduce it down to something that could fit on a watch or fit on a phone.
Got it.
What is really...
It's a lot of information and it's specific to like, what you're looking for and it's not out there somewhere. It's just on your hand. It's not on anybody else's. It knows everything about you and nobody else.
Right.
Okay.
And there's a lot of risk to this too. Like if you think of what are the legal implications, right? If you think about data, like data is regulated and handled differently across the entire world.
Yeah.
And, what really is the use case of the Great Wall as an example, the Great Firewall of China, if everybody's got on-prem devices with their own essentially data generators or AIs that are going to help them get exposure into the world. So many things will change, right? The idea of security and how we secure edge computing will change, right? We will probably always have to encrypt and secure data, but we go through extreme lengths to encrypt centralized data, right?
Yeah.
Versus device data. So you're just going to see so much difference. The interactivity, imagine we've seen LLMs, we've all started to use them and tried ChatGPT. Imagine being able to have a conversation with a device without any noticeable delay on your watch, right? Or on your eyepiece, your Google Glass or something like that. It's kind of like a Halo-like environment of what the future could be in another 5 to 10 years. And I really don't think it's that far off from compressing these models down to something that's usable.
What's kind of stopping it from going crazy right now? Is it cost, or it's not there yet from a technology standpoint, or?
The models still take quite a bit of compute and memory usage to run locally. I'm able to run a 7 billion parameter model on my laptop, right? Which is pretty good. It answers a lot of questions, but it's a generalized model that's used to answer any question. I think what you're going to see are these models that are specifically trained for use cases. We talked about this with Reltio a while back, like a Reltio customer service rep, right? Or a customer support rep. You're going to see these specialized models come out that are trained and tuned for a use case that can be much smaller and much more efficient and faster. And when we get to that point, what you're going to see is these models can actually be put on devices because they're that small.
Yeah. Okay. And there's one other question that you might have touched upon a little bit, but I don't think in depth. How do LLMs, developed by OpenAI and others, intersect with the world of edge computing, and what are the implications for both the tech and the legal sectors?
Yeah, we touched on a couple of these already, but I think it's, the performance and the efficiency, the data privacy, the legal implications of, if you have essentially a on-prem server in your pocket, and there's different restrictions in different worlds, and you hop on an airplane, right? What are those implications, and how do you monitor and control that as a government? The infrastructure and the cost, right? running huge, large models is still going to be a challenge, but as they get lighter and more efficient, we'll be able to run them on anything. And then the interactivity, right? Like being able to communicate and seek advice, regardless of whether you have network or an internet. You can do things like have entertainment or education or customer service or diagnostics wherever you are from your device, because your device is creating that data.
Well, Mike, we covered a whole section on edge computing. Who knew? That was awesome. Well, Mike, thanks so much. It's always great to pick your brain around topics like this. We'll have some other topics coming up that I'm really excited about, and I know you are too. But thank you, everyone, for listening in to another Data Hurdles. Don't forget to rate and review us. I'm Chris Detzel, and
I'm Michael Burke. Thanks for tuning in.
Thanks, everyone.